For this example, we are going to try to set up an integral that represents the region bounded by the following curves. So this is just a setup problem. If you want to practice the algebra afterwards, that's fine. One thing that you should do is you should always take a quick sketch to see what the scenario is. So the square root function looks like this. Okay, y equal to 0, that just means that it's going to be bounded here on the x-axis. And then you have y is equal to 3 minus x. So you know the y-intercept is 3, and then the slope of negative x means that it's going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. So this will be your last graph. Now the reason why this is really important for you to sketch out the scenario first is this is a problem where actually two integrals will be involved, because this right here is the top function of the first integral, this is the top function of the second integral. So that means that we need to find the point of intersect. So that would be our first step, is to find the point of intersection. So look at the two curves. What two curves are being intersected right now? That's going to be the square root of x is going to be intersecting with 3 minus x. How do we solve a square root equation? Well, we would isolate the root and then we would square both sides if it was a square root problem. So this gives us x is equal to, and then foiling this out, you're going to get 9 minus 6x plus x squared. This is going to be a quadratic function now, right? If you see a quadratic, that means that we need to implement those skills from algebra. So that means we want one side equal to 0. So when you do that, you get 9 minus 7x plus x squared. And then you would ask yourself for a brief moment, hey, can I factor this? What two factors multiply to 9 and add to negative 7? And if you cannot figure that out, then what you would do is use the quadratic formula to quickly get the answer to this. So that's what we're going to do here. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, cleaning this up, we get 7 plus or minus the square root of 13 all over 2, and that would be your 2x answers. Okay, but take a look at the scenario here, right? Plus or minus means that, yes, we do have two possible situations, but look at your only possibility. It's going to be one of these answers. So if you grab your calculator and type this in, you're going to get two answers. You're going to get, and if we round to 4 decimals, we're going to get 1.6972, and we're going to get 5.3028. Okay, which is possible for this scenario. Okay, so the only answer for this scenario would be this intersect, because 5 is somewhere over here. You could also double check to see if remember when you're solving these types of problems, that you need to always check both solutions satisfy. So this is going to be the solution that we have for our intersect. So then we will set up the integrals. Okay, and use the diagram that you have sketched out to help guide you. So our first integral is going to be from zero to that point of intersection. And what function is on top? Well, that is your square root function. So this will be the square root of x with respect to x. And then we're going to add this to our second integral, which will be from the starting point is going to now be from our point of intersect. And then what is the top function now of that, right? So we're going to be integrating it from 1.6972 all the way to 3. So if you didn't know that intersect, right, you would have to figure out, well, when does this line intersect with the line y equal to 0? So if you didn't already calculate that, you would go ahead and do that to get this upper bound. And again, that top function there is going to be 3 minus x with respect to x. And that is the setup for this problem, and you're all done.